Good morning. All right, so here we have a fraction with the square root on the top and bottom, and according to tradition, we're not supposed to have square roots in the denominator. The denominator is the bottom of a fraction, on the bottom. So to rationalize the denominator means to not have square roots in the denominator. The normal way we fix this problem, we're not supposed to have square roots on the bottom of a fraction. Here we have the square root of 5 on the bottom. One method is to just multiply the top and bottom by that square root, which gives us the square root of 100 over the square root of 25, which gives us, let's see, the square root of 100 is 10, square root of 25 is 5, so this equals 2. Another approach, which would give you the same answer, let's start over. Let's see if I have the square root of 20 over the square root of 5. Another approach is to break that 20 up into its two factors, or two of its factors. 4 times 5. So up top, if I break the square root of 20 into the square root of 4 times the square root of 5, and the bottom if I leave the same. Now I can just math ninja the root 5s, and I get the square root of 4, which is 2. And as you can see, these are the same thing. You can choose which method you like. The goal is to not have a square root in the denominator. Let's try another one. Okay, so here we have the square root of 6 over the square root of 32. I kind of like the method we did just a minute ago where we broke it up into its two factors. That seemed to be a nice way to go. Let's see, 6 can be broken up into 2 times 3. I'm leaving both of those factors in square roots since the 6 was in a square root. And let's see, a like factor, 2 times 16. 32 is 2 times 16. Okay, so we can math ninja the root 2's. And now let's simplify what we have left. Let's see, we have the square root of 3, and the square root of 16 is just 4. The result here is a fraction that we don't have a square root in the denominator. Once I get to that point, assuming I can't simplify anymore, I'm done. I don't want a square root in the denominator. This is called rationalizing the denominator. No fractions on the bottom of the fraction. Let's try one more. Okay, here we have the square root of 3 over the square root of 48. Now, we could multiply the top and bottom by the square root of 48. If I could write a 48. But as we saw before, it seemed a little easier if I could break that up into common factors and simplify that way. So I'm going to try this where I break that 48 up into a common factor. 3 goes into 48. Let's see, so the top is going to remain the square root of 3, and the bottom, that's root 3 times root 16. 3 times 16 is 48. The root 3's can cancel, and let's see, that'll give me 1 over the square root of 16. Well, the square root of 16 is 4, so this is 1/4. All right, let's do one more that's a little trickier. All right, let's try this one. Last one. Okay, we have the square root of 6 over the square root of 8. Let's see, the square root of 8 is 2 times 4. Square root of 6 is 2 times 3. I can cancel out the 2's, the root 2's, and I'm left with square root of 3 over square root of 4. So let's see, this is the square root of 3 over 2. You know what, maybe I better try one more. All right, let's say we had the square root, let's make this a little more interesting. Let's say we had 2 times the square root of 3 over, let's say 5 over the square root of 7. Okay, so we're not supposed to have square roots in the denominator. On this particular example, 5's fine. It's not a square root. It's only the square root of 7 that's given us issues. We're not supposed to have square roots in the denominator. So since I can't simplify or break apart anything in this fraction the way it is, the numbers in the square roots are prime, so they're not going to break up. I'm simply just going to multiply the top and bottom by root 7. So let's see, that gives us 2 times the square root of 21 over 5 times the square root of 49. The square root of 49 is 7. So I have 2 times the square root of 21 over 5 times 7. Well, 5 times 7 is 35. And there we go. As long as I don't have a square root in the denominator, we're good. This is called rationalizing the denominator. Only rational numbers are supposed to be in the denominator of a fraction according to tradition.